I welcome you all for this session. Today I have choose the topic Bernoulli's rule. This rule will helps you to solve the problems of Fourier series. So now let us see how we define Bernoulli's rule, or that is integral of uv dx. Integral of uv dx is equal to u into integral of v dx minus differentiation of u, that is u dash, integral of integral v dx plus double derivative of u triple integral of v with respect to x minus plus etc. You are going to continue until the derivative is 0, until the derivative gets 0. So how you are going to decide u and v? How you are going to decide u and v? So by using I-late rule, the rule called I-late. So I represents inverse trigonometric function. L represents logarithmic function. A represents algebraic function. T represents trigonometric function. E represents finally exponential function. Once you have the knowledge of this I-late rule, then it is easy to apply Bernoulli's rule. So according to the I-late, the term I represents, if you get inverse trigonometric function in the integral, sine inverse, then you can consider that term as u first. Then if you get sine inverse x into log x, then log x is legitimate logarithmic function, so then you can consider log x as v. So first term, the preference will be given as I, L, A, T, E for u and v. Okay, so knowing this minimum concept, I'm giving some examples to solve the problems under Fourier series with definite integrals, with definite integrals, that too definite integrals. So let us see let us consider the first problem in that first example, or that is integral 0 to pi x sine x dx, x sine x dx. So in this, now x is named as what? X is named as algebraic function. What is x there? It is an algebraic function. What is sine x? It is a trigonometric function. X is what? Algebraic function. So sine x is what? Trigonometric function. Go through the I-late there. So first we have algebraic function. So x represents u in this given integrand. So then we have trigonometric function. So sine x represents v. Sine x represents v. Sine x represents v. Now let us apply Bernoulli's rule to this. So the rule says that what? U. First write down u. The term u is here x. The term u is x here. And now here you should know minimum concept of integration. Integral of sine x. What is integral of sine x? Integral of sin x is what? Minus cos x. Minus cos x. Similarly, let us know, also we shall know what is integral of cos x. Integral of cos x is sin x. Integral of cos x is sin x. Knowing these two basic integral, let us solve this. U into integral of v. Integral of v means integral of sin x. Integral of sin x is minus cos x. I have given there minus cos x. Minus cos x. Minus, the rule says that minus, differentiate x. The derivative of x is 1. The differentiation of x is 1. Now integral minus cos x. Integrate minus cos x. Minus is constant. Integral of cos x I have given here. Integral of cos x is sin x. So you are left out with sin x. Integral of cos x is sin x. Next, minus a plus, differentiation of 1 is 0. So 0 into anything is 0. So we will end at this stage for integrating. So now as we are integrating with definite integral, we apply the limits as x is running from 0 to pi. Next thing, you should know basic concepts of trigonometric function with standard values. So we know the standard values of cos 0. Cos 0 is 1. Cos n pi. Cos n pi is minus 1 power n. Sin 0. Sin 0 is 0. Sin n pi. Yeah, sin n pi is always 0. So knowing these simple values, apply the limits now. When I apply the limits for the second term, if you go with the simple simplification, it will be represented as minus x cos x. So here minus into minus, minus into minus, plus minus into minus, plus sin x, limit x equal to 0 to pi. X equal to 0 to pi. So now I will apply the limits for the second term. Upper limit, always while applying the limits, you should apply first upper limit, then lower limit. Upper limit minus lower limit. So when I give in place of x, I will substitute pi. Sin pi. Sin n pi is what here? Sin n pi is what? 0. Sin pi. Sin 1 pi is also 0. Sin 2 pi is also 0. Sin 3 pi is also 0. So sin 1 pi is 0. Minus lower limit, where x equal to 0. Lower limit is x equal to 0. Sin 0 is 0. So upper limit minus lower limit, the value is terminating to 0. So you are finally left out with minus x cos x, limit x equal to 0 to pi. Now substitute the limits. So when I substitute upper limit, x equal to pi into cos pi minus x, when I give x equal to 0, 0 into a real value, cos 0 is 1, 0 into cos 0 is 1. So 0 into 1 is 0 itself. And now substitute the value of cos pi. Cos pi, I have given cos n pi value. Cos n pi is minus 1 power n. So here cos pi means it is nothing but cos 1 pi. When I give n equal to 1, it becomes minus 1 power 1. Minus 1 power 1 is what? Minus 1. Minus 1. Minus 0. So it is, you are left out with minus of minus 1 into pi is minus pi minus 0. Minus 0. So minus pi minus 0 is what? Minus pi itself. Minus pi, minus of minus pi, minus of minus pi is plus pi. This is the way to integrate the given value called 0 to pi x sin x dx. So this is the way to integrate the given problem. Now let us consider